guys. Today's video is on the last type of factoring. We're going to talk about some special factoring. This includes difference of squares. So we first talked about GCF in the first video. Then we went to factoring polynomials with four terms. That's called grouping. We talked about maybe a mixture of GCF and grouping. We then went to trinomials where we found our magic numbers. And we also had a little bit of GCFs and trinomials together. Here it's called difference of squares. We use this method not for trinomials, not for polynomials, but when we have a binomial where both terms are perfect squares and there's subtraction between them, they're being subtracted. Let me write down examples of perfect squares. You could have a number like 4 or 16 or 100 and so on. You could also have variables like x squared is a perfect square. We can take the square root of x squared to equal x. We can do x to the fourth power. We can do the square root of x to the fourth to equal x squared. The reason why I know this is because, remember, square root means what number can we multiply by itself to equal the number on the inside. Here we did x times x, made x squared. What number can we multiply by itself to make x to the fourth? X squared times x squared. X to the sixth is also a perfect square because what number can we multiply by itself to make x to the sixth? It's x to the third, because remember we do product rule, we add the exponents. Another type of perfect square not only could be a number like a constant or a variable, but it could be a combination of the two, such as let's do 4x squared. That's a perfect square. We can do 16x to the fourth, where they're square root. So if I want to do the square root of 4x squared, you do the square root of the 4, and then you do the square root of the x squared. Or if you wanted to find the square root of 16x to the fourth, you do the square root of 16, which is 4, and then the square root of x to the fourth, which is 2, kind of cutting it in half. You can also have a number, a variable, and another variable. So let's say 25x squared, but then I can put a y, maybe y to the fourth here. So these are all perfect squares that you can identify when you have a binomial and there's a subtraction in between. So if you see any of those and you see a binomial, you see subtraction, think difference of squares. The formula you're going to use is that if you see your two perfect squares with a subtraction, you're going to split it up into your two parentheses, your two factors, and you're going to put the square root of each with a plus sign and the other one with a minus sign. Let's do some examples. Number one is a binomial, and the x squared and the 81, they're both perfect squares. That's perfect. Great job. So now we can do our formula. The way we start is we do the square root of each. Their square root of x squared is 9. And the square root of the square root of x squared, I was thinking the other way around. The square root of x squared is x. I'm sorry. And the square root of 81 is 9. The way we write our final answer is we take those two perfect squares and we write them in this order, A, B, A, B. One has a plus, one has a minus. It doesn't matter if one has a minus here or one has a plus here. Commutative property says that. And if you wanted to check your answer, here we're checking. We get x squared minus 9x plus 9x minus 81. The middle combining like terms cancel, and we get what we started with. Example number 2, x squared is a square root. It's a perfect square. Great job. 144 is a perfect square. However, since there's a plus sign in the middle, we cannot use this formula. Therefore, we cannot factor by difference of square, and we write prime. That means there is no simplification that we can do to this binomial. Let's do number 3. 4x squared is a perfect square, and 16 is a perfect square. Let's find out what their square roots are. This one is 2x. 16 perfect square is 4. One has a plus, and the other one has a minus. And again, you would check your answers through your double distribution or your foiling. Let's do another one. Number 4. It's weird because there's a y here. But we do know that these are both perfect square roots. The square root of 9x squared is 3x, and the square root of 25y squared is 5y. The way you write your final answer is you put a plus between them, and then the other factor, is going to have a minus between them. And again, check your answer through distribution. I'll do that here. 3x squared minus 15xy plus 15xy minus 25y squared. The middle cancels. And you're left with, I think this was supposed to be a 9x squared y squared. So we know we got it right. The next two problems are a little bit more challenging. Let's look at those. Number 5, 8 is not a perfect square. So what is this problem doing here? This is an important problem because before you start any factoring, grouping, or trinomials, or even this difference of square, you always look for a GCF. Here there is a GCF. The GCF is 8. 8's the biggest number that can be taken out of these two terms. After taking out an 8, we're left with x squared minus 1. A lot of you would think you're done. You don't think you could do anything else. You took out the GCF. But now this inside the parenthesis, this binomial, is a difference of square. X squared and 1 are both perfect squares. So we can do just like we did for 1, 3, and 4, where x is the square root of x squared, and then 1 is the square root of 1, and we write a plus sign with one and a minus with the other. Do not forget to bring down your GCF that you had in the beginning. Put that in front at the end of the problem. Because if you forgot it, if you did your distribution, you would not end back up with the 8x squared minus 8. You would get something totally different. Okay, so remember your GCF and check to see if after you take out the GCF, what you have left is still a difference of square. b to the 4th here, these are both perfect squares. The square root of a to the 4th is a squared. The square root of b to the 4th is b squared. One has a plus, one has a minus. But the reason why this is a tricky problem is that once you factor, check to see if one of your factors is another difference of square. This one here is a difference of square inside another difference of square. So we can keep factoring this to a plus b, a minus b. Again, we know to keep going because these are both perfect square roots. It's a binomial and the minus sign in between. The first factor is a squared plus b squared. They're both perfect squares, but because there's a plus sign and not a minus, we would leave it like that and we don't need to keep going. Here's your final answer. You could keep doing your double distribution to eventually check to see if you get the right answer. I'm not going to do that in this video. Write down what questions you have. The bottom of this page we're going to do in class. I want to make sure everyone understands the beginning part first. Have a great night. See everyone next time.